In June 2026, a security researcher operating under the name 0x Florent pulled off something resembling a digital rescue mission. He successfully extracted $2 million that had been completely frozen inside an abandoned crypto project called Hongcoin for 9 straight years. The money was stuck because of a specific flaw in the original 2016 code. It's called an integer overflow bug, a quirk in older versions of the Solidity programming language, where a number hits its maximum limit, wraps back to 0, and causes functions to fail. Here, it permanently disabled the contract's automatic refund mechanism. 0x Florence spent months reverse engineering the contract's bytecode. He designed a precision exploit to deliberately trigger that exact same overflow bug in a controlled way, legally tricking the system into finally releasing the trapped funds to their original owners. Hongcoin isn't an isolated case. Across the blockchain ecosystem, an estimated $500 million remains locked in similar legacy contracts, the result of failed ICOs, abandoned projects, and technical errors from a decade ago. This stranded capital highlights the long-term liability of technical debt. The move fast and break things era left behind massive unresolved vulnerabilities that require this level of expert intervention to clear, as developers realize that the shortcuts taken in 2016 are still impacting the balance sheets of 2026. We are seeing a similar correction in consumer electronics. Major hardware manufacturers are beginning to prioritize practical, everyday usability over chasing theoretical performance maximums or experimental aesthetics. Samsung, for instance, spent 7 generations pushing a tall, narrow design for its foldable phones. This required users to unfold the device for almost every basic task, causing significant premature hinge stress and component fatigue. The Galaxy Z Fold 8 Wide addresses this design debt. By shifting to a balanced 20:9 aspect ratio, the cover display is finally wide enough for standard use, reducing the need to unfold the device and helping push the hinge's durability rating to 300,000 folds. The monitor industry is facing its own legacy issue with OLED technology. While the color quality is high, these panels have historically struggled with low peak brightness and a high susceptibility to permanent image burn-in. Dell and Alienware are addressing this with Penta-Tandem technology. Instead of arranging subpixels horizontally, this method stacks independent color layers vertically. By concentrating the light output, these panels hit 1,300 nits of brightness, making OLED viable for well-lit rooms. AMD is also pivoting toward pragmatism. Their global launch of the RX 9070 GRE at $549 targets the mid-range market, focusing on memory capacity and value rather than competing solely for the high-end performance crown. These shifts suggest that hardware companies are realizing that long-term market survival now depends on solving these fundamental consumer pain points rather than relying on the novelty of experimental features. While hardware design flaws frustrate users, architectural flaws in software can lead to systemic collapse. In April 2026, the DeFi protocol Aave faced this reality during a $230 million hack. The breach revealed a critical vulnerability in how protocols interact. Aave's internal smart contracts were secure, but the external infrastructure they relied on failed. The attacker compromised the Layer 0 bridge's single verifier to control data validation between blockchains. They pushed a forged message, minting unbacked counterfeit tokens. These worthless tokens were deposited as collateral into Aave to borrow and steal $230 million, draining the protocol's reserves. Aave has since overhauled its standards, mandating security audits for third-party bridges and oracles. It is an admission that they must protect the entire ecosystem, not just their own code. The hack proves that in a connected tech environment, security is a chain. A perfectly written standalone protocol offers no protection if the bridges it relies on are structurally vulnerable. The frantic bug fixing and design pivots of 2026 contrast sharply with the methodology of companies that have spent years preparing for these exact market shifts. Apple is currently executing a roadmap to enter the $200 billion eyewear market, with smart glasses scheduled for late 2027. Their strategy avoids the high-cost, isolating nature of VR headsets. Instead, they are targeting the $200 to $500 price range with glasses designed for everyday use, directly competing with the form factor currently popularized by Meta. Apple is following the same integration strategy they used for the Apple Watch. By tying the hardware directly into the existing iPhone ecosystem, They turn a new accessory into a necessary extension of a user's digital life. Success will require overcoming significant barriers, specifically the established eyewear monopolies and the privacy concerns inherent in wearable cameras. These developments in 2026 signal a change in industry priorities. The focus is shifting away from shipping the first prototype and toward the much harder task of integrating security, hardware durability, and ecosystem-first planning into a single product.